In this lesson, we're going to look at finding the nth term in an arithmetic sequence. All right, so how do we find the nth term in a geometric sequence? Well, to find the nth term, we need to look at the two formulas that that represent the arithmetic sequences and the geometric sequences. Well, the arithmetic sequence is the f of x, or the y, is equal to mx plus b. And we've been working with this for a long time. The m is our slope, and the b is the y-intercept, or the starting point. Now, I'm going to put down the formula for the geometric sequence, but then we'll talk more about that later. So for the geometric sequence, we've got the f of x is equal to a times b to the x power. All right, so example 1, how do I represent the arithmetic sequence and find the nth term? So what sequence is represented by the equation the f of x is equal to 5x plus 2? Now, in a sequence like this, remember, we have the different terms. This is going to be my first term, my second term, my third term, my fourth term, and then my fifth term. So in finding the sequence, what we're going to do is we're going to plug in the terms. So I'm going to plug in, let's just write this down over here. We've got the f of x is equal to 5, and for the first term, we're going to plug in a 1. And then we're going to plus 2. So 5 times 1 is 5, and 5 plus 2, then 7. So the first number in our sequence is going to be 7. Now, we're going to continue this pattern by now plugging in, instead of a 1, we'll plug in the 2. So we have 5 times 2 is 10, and 10 plus 2 is going to give us then 12. And then we'll repeat it again. So we'll have 15 plus 2 gives us 17. And you're probably noticing right now that there is a pattern. And notice what's happening here is that this one's being added by 5. This is adding 5. So if I just wanted to continue my pattern and not plug them in, we could just continue by adding 5 here. And then I'll have 22, and I'll add 5 again, and I would have 27. So now it's asking, what is the 100th term in the sequence? So it would be like extending this pattern all the way out until we get to the 100th term. Well, as we did for the other terms, we're going to plug in then 100 for our x. We've got the f of x is equal to, we have the 5 times then 100 plus 2. Again, we're just plugging it right into here. So this 100 is getting plugged in for the x. So I would have 5 times 100, we have 500, and then we're going to add 2. So the 100th term is going to be 502. All right, question number 2. What is the sequence represented by the equation the f of x is equal to negative 2x plus 20? Well, again, just like we did in number 1, we're going to plug in our terms, and the terms are our x, and then the sequence is what we get for the f of x. So if I plug in a 1 right here, I have now the f of x is equal to negative 2 times 1 plus 20. So we have negative 2 times 1 is negative 2, and negative 2 plus 20 gives us then 18. All right, so for our second term, we're going to plug in then 2. So we've got the f of x is equal to 2, or negative 2 times 2 plus 20. So we have negative 2 times 2 is negative 4, and negative 4 plus 20 will give us then 16. And then for the third term, f of x is equal to negative 2 times 3 plus 20. So negative 2 times 3 is negative 6 plus 20. And so then we're going to then have, so we'll be at 14. Now, if I wanted to extend my pattern, now notice that what's happening is I am going down by 2 each time. And I also want to point out here, notice that that's the slope, that's the rate of change. And so if I wanted to go down by 2 here, I could just say, well, 14 minus 2 is 12. But now when I get to that 50th term, I'm going to need to plug that one in because I can't unless I want to go all the way down and keep subtracting 2. So I've got the f of x is equal to negative 2 times 50 and then plus 20. So negative 2 times 50 is negative 100, and I'm going to add 20 to that, and I will have negative 80. All right, example 2, how do I write equations for arithmetic sequences? So our arithmetic sequence is the same thing as the slope-intercept form, is the f of x is equal to mx plus b. And remember that in chapter 5 that we talked about that m being our slope or the rate of change. We also just talked about it for the sequences being the common difference. They're all the same. And the b being the y-intercept or the starting place on the graph. So let's look at the pattern that we have in our graph. And I'm going to label this my x and then this be my y. Remember to find the slope or the rate of change. It's the change in the y all over the change in the x. And so I'm looking for how much I'm going up or down in the y, and I'm going up 2. And in the x, we're going up 1. And again, from 7 to 9, I'm going up 2. And then in the x, I'm going up 1. So when I'm looking at my slope, or we also call that the rate of change, or we also look at it as a common difference, our slope that we have here is equal to 2 all over 1, which is equal to then 2. The change in the y value all over the change in the x value. Now let's talk about finding the y-intercept. Remember, we said the y-intercept is when x is 0. But notice that our terms start at 1. So in order to find the y-intercept, I need to back up 1 and find out what the y value is when the x is 0. And so to do that, we could simply just back up on our table, and instead of adding a 2 to the next step to that value of 5, we could subtract 2, and then we would have a y-intercept. Remember, the y-intercept is when the x is 0. So the starting point on the graph is going to be at the 3. So we'd start at the 3, we go up 2 over 1. So to write an equation for this, we're going to have y is equal to then our slope of 2, and then our y-intercept of 3. So we need this equation, the y is equal to 2x plus 3. We need that in order to find that nth term. And our nth term here, what we're looking for is our 50th term. Because what we don't want to do is to continue that pattern going all the way up to 50. That would take us a long time. We certainly could do it, but it would take a long time. So instead we've come up with the equation for the table, and we're going to plug the 50 in for the x. So that 50 is going to come right in here and replace that x. So I have y is equal to 2 times 50, and then we're going to plus the 3. So we'd have y is equal to then 2 times 50, 100, and so we'd have 103. So to the 50th term is 103. All right, question number 2. Let's write an equation to represent the sequence. All right, so let's go ahead then and let's make this into a little xy table. We've got our first term, we have our second term, our third, our fourth, and our fifth term. And so let's go ahead and find then our pattern. And from 64 to 60, we went down 4, and we're going up 1, down 4, up 1. So we know that our common difference, or the slope, is equal to negative 4. All right, so again, we need to be writing then the equation. So right now we know that we've got a y is equal to, or the f of x, negative 4x, and now we have to find that y-intercept. And remember that the y-intercept is when you back up, and we have the y-intercept is when the x is 0. So we kind of need to know, like, what is the 0 term there? So instead of minusing a 4 to go from here to here, because these were going this way, we would want to add a 4. So 64 plus 4 would give us 68. So we know that our y-intercept then, when x is 0, is going to be 68. So here's our equation for this sequence. And then to find the 25th term then, we need to plug in, we're saying then when x is 25, what's y going to be? So we're going to plug in 25, so we're going to take our y is equal to negative 4 times 25, and then plus 68. And so when x is 25, y is going to be equal to negative 32. So I'd have negative 32 right here. So the 25th term is negative 32. Question number 4, which of these is the equation that generalizes the pattern of the data in the table? Well, let's take a look at our table and see if we can find any patterns. So we're going from negative 5 to 1, and that's going up 6. But then let's look at the change in the x. So the change in the y is going up 6. The change in the x is going up 2. And then we're going from 1 to 10, and that's going up by 9. And from negative 1 to 2, it's going up by 3. From 10 to 19, again, going up 9, and then going up 3 here as well. Now notice how it may appear that we don't have a constant rate of change. And so looking at this, you would want to find, when finding the slope, you would want to take the change in the y all over the change in the x. So I've got our slope is 6 all over 2. Well, that simplifies to 3. And let's check the next one. Let's check the 9 all over 3. So we have 9 all over 3. Well, notice how then when you do simplify them, or when you do take them as a ratio, they are the same rate of change. It's going up by 3s as the pattern. And so looking at our choices that we have right here, we could eliminate knowing that the rate of change, or the slope, is the number with the variable. So we could eliminate 2 of these. And so what we need to find now is what the y-intercept is. And remember that the y-intercept is when x is 0. So somewhere in here, like between this negative 1 and 2, we'd have a 0. So we could try to back up on that one. But notice then how we have these choices here. Let's go ahead and, instead of doing that, let's go ahead and just plug in some of these x's and f of x or the y and see which ones work. And we want to at least do 2 of them. It has to work for all of them. So let's try this one right here. So if I have the f of x is equal to 3x, well, let's plug in this negative 3. And I had, for the f of x, I had negative 5. So I have, is negative 5 equal to 3 times negative 3, and then that's going to be negative 9. Well, when you find that one of them doesn't work, you know that they don't work, that it's not going to work as your sequence or your pattern. So we know it's not going to be A. So let's check D. I have the f of x is equal to 3x plus 4, and let's plug in our negative 5 for our f of x, and 3 times negative 3 plus 4. So I have 3 times negative 3 is negative 9 plus 4. That's going to give us negative 5 over here. And is negative 5 equal to negative 5? And it is. And so you'd want to check maybe another point by plugging them in. Let's maybe do this one right here. 1 and negative 1. Well, is 3 times negative 1 is negative 3 plus 4. Is that equal to 1? Yes. So we know that the formula for this pattern is the f of x is equal to 3x plus 4.